Okay, if you just got in, we're probably going to start about now. By probably, I mean we are going to start about now. So welcome to day one of the Team 2539 programming workshop. As you can see here, we're going over a few things. It's September 9th, 2024 for anyone watching the playback video. But welcome, thank you all for coming. We understand that the beginning of the school year can be a busy time, and we want to thank you guys for coming out to our programming workshop. Schedule-wise for today, we're going to be giving you a short overview of FRC, our robotics team, and what you're going to be learning over the next 3 weeks. Then we're going to cover some basics of the Java programming language. After that, we're going to learn some Java specifics about programming robots, of the very basics. And after that, there's going to be a little lab period where if you have a physical robot, you'll be able to write some code to test it on that. If you don't, you can write the code anyway. And we'll have a little example project of what that'll look like when it's done available. Yeah, so what is FRC? You guys probably all know what FRC is. Each year there's a game, robot sub-teams. It's a 6-week programming competition, not programming competition, robot building competition, right? For us, though, in the programming area, it's a bit of programming competition-ness. So we have sub-teams-wise mechanical, CAD, electrical, and programming, which would be us, right? So we kind of need to take the robot, get it from its constructed state, where it can't really do anything but just sit there, to something where you press buttons and it does stuff, to put it in very simple terms. So this is day one of a 6-day workshop, and we're going to be going over Java, motors, sensors, and controllers. By the end of the training, you should be able to kind of fully program a robot. But we're going to start with our Java fundamentals because they're fun and fundamental. So we're going to go over variables, conditional statements, methods, and classes. Also, if you have a question, you can just unmute your microphone and ask, or type it in the chat, and we'll try to see that. So Java variables are basically containers for storing data, right? Like a name would be a variable, a birthday could be a variable, your age could be a variable, right? In Java, we have different types of variables. For example, strings that can store text. For example, hello is a string. String values are surrounded by double quotes. We have integers, right? They store integers, whole numbers, without decimals, like 123 or negative 123. We have doubles, which store floating point numbers, aka decimal numbers, right? So not integers, anything that would be continuous, like 19.99 or negative 19.99. These are also good if you need to store really small numbers or really big numbers. And also Booleans, which store two states, either true or false. Now, pay careful attention. The string is capitalized here. That is important, and the rest are not capitalized. So to make a variable, first you put the name of the type first, like integer or string. Then you put an equal sign, and then you put the value you would like to set the variable to. I think I might have accidentally omitted it, but you put the name of the variable in there as well. So for example, here we're creating an integer that stores a number, and that number is 5. So we put int, the type, integer number, which is the name of our variable, and then equals 5. So that very simply creates a integer variable. And then we do the same thing for a double here, where we have our approximation of pi to 4 decimals, which, as you can see, is not an integer, which is why we need to use a double. And our name there is decimal letter. And notice at the end of these, you need a semicolon as well. That's kind of to tell Java, the programming language, that you're done with your statement. So usually at the end of pretty much every line, I see a semicolon. So that just lets Java know it's time to move on. Here you see a string, and as you see, you have those double quotes. So you can't just write out the text. You need to put double quotes around it. Otherwise, it might get it confused with variables or something else like that. And here we have a Boolean, right? Is a cow. That's something that can either be true or false, right? It's either a cow or it's not a cow. And right now it's not a cow. It is false. So you see there, false, all lowercase. An alternative value for that would be true, which would also be spelled all lowercase. Now, if you've already defined a variable, like if you follow my cursor, up here, we defined integer number. When you set it again, you don't use the type because Java already knows the type. So you would set it right here, and here we're setting it to 3. So then here, this is how you print out anything really, in this case, a variable. And this would print out 3 because up here, we set it to 5. Here we set it to 3, so it's now 3 instead of 5. And then we print it out. So this is where if you have a Java editor set up, or I would actually recommend this QR code if you don't already have one set up. Yeah, basically any Java editor really, like Program is, Java compiler. This one works perfectly fine, but you can pretty much test your code out here. So I'll send this out in case you don't have a device. Okay, we got it. But so anyway, for our try it, you're gonna store your name, your age, you think bots are cool, and the probability of a coin landing as a decimal. And then you're gonna want to print those. So this is a review for how to print those if you want. And then again, to create a variable, you need the type, you need the content, like the name of it, and then what's in the variable. So if you guys have any questions, you can ask them. I'll give you guys a minute or two to do that, show you the answer. Okay, so if you need a little more time, that's okay. This is kind of new, but we're going to move on to, you can kind of ignore, but this is the solution that we would have at least, right? Our string name equals Krypton Cougar name, because our name is a string of text, right? Is not a number, it's not a Boolean, and it's not a something else about this specifically earlier is this final bit. What this, your variable is never going to change, right? You would use this if you have something called a constant, which is a variable that never changes pretty much. Like the value of pi is a constant in mathematics. It's a lot like that. Our team name is possibly never going to change, probably never going to change. We would make this a final, right? Now, age, on the other hand, usually changes every year. So we don't have the final there. And most of the time, you refer to your age just as an integer. Like I'm 17, the team is 17 years old, right? You could be 18, but usually you wouldn't say I'm 18.67. So we're calling it an int for now. And that's how you define age as an integer. Are robots cool? If you think robots are cool, yes. If you don't think they're cool, no. So if you think they're cool, it's true. If you don't think they're cool, it's false. We, as a robotics team, think they're pretty cool, so it's a true. And then we have the probability of a coin flipping heads is 0.5, because as a proportion out of 1, 0.5 of the time, a coin is going to flip heads. So that's also final, because hopefully the laws of probability and the laws of physics aren't changing enough for us to make that change. And then we just print them out. And this is our result. So conditionals are specifically for dealing with Booleans, right? For numbers, you can pretty much just use the default symbols you learn in math, like plus, minus, divide, multiply. But less for conditionals, you're going to need to learn a few new things possibly. So we have the less than operator, which basically returns true, or it kind of evaluates to true if A is less than B. And a very similar thing happens for the rest of these. A is less than or equal to B is written as a less than sign and then the equal sign. And this will return true if A is less than B or A is equal in value to B. And these only work for numbers. These 4 only work for numbers, by the way. Greater than is just the opposite of less than, and greater than or equal to is just the opposite of less than or equal. Now, equal to will return true if both of the numbers are the exact same, right? So 5 and 3 would return false, 5 and 5 would return true. And then not equal to returns true if they're not the same. And you can also use these two on Booleans. So logic-wise, we also have an and. Now, and returns true if both A and B are true. So if A was true and B was false, it would return false. If A was true and B was true as well, it would return true. Then or it returns true if either of them is true. So if A was true and B was false, it would return true. If A was true and B was true, it would return true. But if both of them were false, then it would return false. And these are just the values that you can just write out for Booleans. Does anyone have any questions? Okay. If you do have questions, you can just leave them in the chat or raise your hand, and I'll try to see that. So if statements are the main way that we end up using conditionals in programming. What you can do is you can put an if here, and then your conditional in parentheses, and then a little curly brace, it's called, and then some code you want to run if your conditional is true. Then you put an ending curly brace, an else, a beginning curly brace, and some code you want to run if that's not true, right? And then finishing curly brace. So this else section is optional. You don't need it. You could just have the if section, and then if your condition is false, it just won't do anything. So here we see an example where we have my Boolean, which is true, and then we have another Boolean, someone else's, I presume, and that's false. So if both of those are the same, right, we'd print out they're the same. And if both of them are different, we'll print out they're different. And we know they're the same because we're using the equal sign comparator right here, which only returns true if both of them are equal. Since true and false aren't the same, this returns false, and we skip to the else section and run this. And we get exactly that, right? It prints out they are different. So if specifies a block of code to be executed if a specified condition is true, and else specifies a block of code to be executed if the same condition is false. Any questions? Else if statements are useful for multiple conditions with different outcomes. So else if is checked if the first condition is false. So for example, we have our variable x here, and it's equal to 5. It's an integer. We check if x is greater than 10, and if it is, we print out x is greater than 10. Now, hello. But now we see in this case, x is not greater than 10, right? So we're going to move on to the next statement. Else if x is less than 2, right? That is also not true. So we move on to the next statement where we finally have nothing to check. It's just else. And we print out x is between 2 and 10. Oops, sorry there. And that's exactly what we see there. So if x were 15, the first statement would get printed out because it would be true. And so it would just run that. If x was 0, first statement would be false. So it would move on to the next statement, and that would return false. Well, I mean, it would return true in that case because x is 0. So then that would run and we would move on. So here's another try it. Basically, create a variable to store a number, another number, then print both if both of them are positive. Print just one if only one of them is positive, and print neither if both of them are not positive. Also, if you just got in, all we've gone over so far is different variable types like int, string, double, and Boolean, and then conditional comparators, and now we're on if statements. So. So in the interest of time, we're going to move on. Hopefully you had a crack at this problem in Program Is or anything you're using to test your Java code out. But the example of our solution that we're going to use is we define a variable x as an integer and a variable y as an integer. And I mean, in your finished code, the numbers depend, the names depend. It doesn't really matter. What is important is this logic right here. So if both of them are greater than 0 or positive, right? X is greater than 0. That returns true if x is positive. Y greater than 0 returns true if y is positive. And then the and will return true if both of those are positive. So that'll print out both if both of them are. Now, if at least one of them is, right? If either x is greater than 0 or y is greater than 0, using this or, we'll print out just one. But of course, we'll only get to here if it wasn't both of them, because we have an if-else statement. And then if we didn't have the case where at least one of them was positive or both of them was positive, we'll get to neither and we'll print out neither. So A, I see you raised your hand. If you just want to like say your question, that's fine. I think you should be able to unmute. A, do you have a question or? Are you guys able to unmute? Can you send it? 1 second. Let me check.
Yeah,
we can use the chat. Oh. So, okay. I think you guys are able to unmute. Okay, thank you, Ryan. I'm going to assume for now that the member named A just has their. Okay, yeah. Okay, we'll move on then if none of you guys have questions. So this would be the solution for the challenge problem, which was doing it with 3 variables. As you can see, what we do here is we just have one case where all of them need to be positive. We have one where any combination of 2 of them needs to be positive. So we have x and y could be positive, or z and x could be positive, or y and z could be positive. So that will knock out any combination of 2. Then we have any combination of 1 would trigger this one. So I guess any individual one being positive would trigger this. And then we have the none again. And there's slightly more efficient ways of writing this code, but this pretty clearly expresses using conditionals. So methods are a way that you can basically rewrite code without rewriting it. They're a way of putting code in one spot and then reusing it, I guess would be a more normal way of saying that. So to create a method, use usually the keyword public and then the return type of the method. So for example, if you wanted to return an integer from a method, you would put int there. If you wanted to return a string, you'd put string. If you wanted to return a Boolean, you would put Boolean. Then you put the name of the method. It's kind of like a variable name, but you use it when calling your method instead of when setting your variable or using your variable. And then you can put as many parameters as you want. Here we just have 1, and here you put the type for the type of parameter and then the name of the parameter. You need to put those in parentheses, and you have braces, any code you want in here, and then you can return a value at the end. If you didn't want to return a value, you would put the word void here, VIOD, kind of like this in example 2. So here in example 1, we just have a method that adds 2 numbers, right? It takes in one integer, num1, one integer, num2, adds them together right here, and returns it. And this method is a static method, which means you don't need to create a class to use it. That you'll see that probably in the next presentation on day 2. We'll go into classes a bit more, but just for now, know that you can use a static method without a class. If it doesn't have the word static, you need a class to use it. Or you need an object of a class. And here we see a method that is just calling a motor and setting the speed of the motor and setting the speed of another motor. So instead of always calling these two methods, instead of calling them both, you could just call run motors anytime you needed to run your motors. And it's also a little easier to remember run motors instead of all these names and the speeds associated with them. Of course, in practice, you could make your methods a lot more complicated than that. So classes, basically, they're a form of kind of encapsulating a bunch of variables and methods. So you start with public class, and then whatever you want to call your class, braces, and then you can put your variables in here, and you can put your methods in here. So here we have a set speed method, which doesn't return anything and takes in a speed that we want to run our motors at. Then it calls a method on the motors using set with that variable as the speed they're going to go at. Additionally, we have a constructor here. Now, you use a constructor when you're making a class or an object of a class. In this case, if you were to make a drive subsystem. Specifically, it's kind of like a special method that basically has no return type because drive subsystem is the return type. And all the code in it runs when you create your object. In this case, we create a motor and another motor and set them to our motor variables. Now, these variables have type motor because they're objects of the class motor. So if we wanted to make a drive subsystem variable, we would, for example, replace motor with drive subsystem, and then we could call new drive subsystem, and that would create a drive subsystem. So that was a little quick, right? If you're still a little unsure about this Java stuff or not super comfortable with it, we recommend Code Academy as a very helpful resource that you can look at between now and the next day. This is a QR code you can use to get to Code Academy, or you could just look up Code Academy Java Practice. We recommend, for our students at least, doing Hello World, variables, object-oriented Java, and conditionals and control flow. The rest of these are useful, but for most robot programming are not necessary. Does anyone have any questions? Okay, we'll be moving on in that case. So motors, sensors, and controllers. There are many types of motors, sensors, and controllers in FRC. Each of them come with their own benefits. We, in our lab, are going to be using the Spark Max motor controller and the Neo motor and the Neo motor with that. And these will be present in the robot we will be writing code for. But in the example project we'll include at the end, we're going to have code for Falcons, Neos, and Talon SRXs. I guess Talon FXs instead of Falcons, because it also supports Krakens. On our robots, we mainly use Talon FX, but a lot of the core concepts are very similar between different motor controllers. So for controlling a motor, you create a class of motor. In this example, we use the can Spark Max constructor to create a new Spark Max. It's on port 2, and it's a brushless type. Most motor constructors won't require that you include the type because they're either brushed motor controllers or brushless. They don't support both. The Spark Max does support both. Make sure you get this right. If you get it wrong, you can blow up your motor or something like that. You can damage your motor if it's brushless and you accidentally say brushed. it will not end well. So here we set the motor to run at 50% speed. This is a really common way of setting motor speed. For most types of motors, you can just do set, and then 0.5 would be 50%, 1 would be 100% speed. If you want to run it backwards, you would just make it negative. So this would run backwards at negative 50% speed. Then if you wanted to get information about the motor, usually there'll be a getter method for that, which you can find in the documentation. Or sometimes your code editor will just kind of show you a list of methods. If you type get, usually you'll get a lot of options for that, which we can demonstrate in the lab later. But this will just print out that motor temperature. Now, sensor-wise, there's quite a few types of sensors that you're going to use on a robot. They're kind of your robot's equivalents of eyes, ears, a mouth. I guess your robot usually doesn't taste stuff, but maybe next year, you know. Ones that we frequently use are mechanical proximity switches, which basically, if something like physically touches it, it'll activate. Magnetic proximity switches, which basically there's a little magnet. Let's say this is a magnet and my hand is the proximity switch. If it goes close to it, it detects it because of the magnetic field, and it's like, I've detected something. There's inductive proximity switches, which are kind of like that, but slightly different. And then there's also photoelectric proximity switches, which I'm not exactly sure how those work, but they exist. These are all basically digital sensors, so they kind of usually give you a yes or a no answer, a Boolean. Then there's distance sensors, like ultrasonic sensors, triangulating rangefinders, and LiDAR. There's also, so ultrasonic sensors, this is an ultrasonic sensor, I believe, of some sort. This one's ultrasonic, but that'll tell you the distance between the sensor and possibly a game piece, possibly a wall, the ground. There's lots of reasons you could use an ultrasonic sensor. And if it's actually returning a distance, it would be analog. So yeah. An example of using a sensor, here we have examples for both analog and digital. For our analog sensor, you just create it using new analog input. And this is basically always the same no matter what sensor you're using, because for the most part, they just get plugged in directly to Rio. They don't go over CAN or anything special like that. And they're pretty simple to read. So you choose the port that you're putting it on, in this case, port 0, new analog input, and then analog input, my analog sensor. To get a value from your sensor, you're just going to do my analog sensor dot get value, and that will return an integer from your sensor. And to get the voltage from the sensor, since it's analog, the voltage it's receiving is going to be somewhere between 0 and 12 volts. Double analog voltage, because it is possible that that value is going to be in between integers, right? Like your voltage could be 6.6 volts from your sensor. And usually you're going to need to convert that into something else. For example, if you're measuring distance, you might get an integer out of it, but that unit of 1 might be like 2.3 centimeters, for example. So you might need to convert that into an actual distance. Now, for a digital sensor, use the port like before, new digital input, my digital sensor. But instead of using get value or get voltage, you just do get, and it either returns true or false. There is no variation. It's either all the way on or all the way off, like a Boolean. Are there any questions? Okay, we will move on then. So to control a motor with a controller, in robot.java, for example here, we have private joystick, my joystick equals new joystick 0. So what this does is it creates a joystick using the joystick class, and it is on port 0. So it's your 0th joystick. which since in programming, we usually start counting from 0, pretty much means your first joystick. Then we also create our motor, CAN_SPARK max my motor equals new CAN_SPARK max on port 1 on our Rio or our CAN bus, and motor type brushless because we're controlling a brushless motor and don't want to blow stuff up. Now in teleop periodic, this will run every 0.02 seconds about my motor.set and then my joystick.getX. This basically is the axis of the joystick. So sometimes forwards and backwards on some joysticks, sometimes left to right, but it gets the first axis and it will set to that. So if your joystick's all the way forwards, it will set the motor to run at 100% speed, all the way backwards, 100% backwards. Now, to detect the button press, what you would do is you get your joystick, and then you get a joystick button from your joystick. The way you do that is use the joystick button class, new joystick button. You put in your joystick, and you include the port that your button is on, the ID of the button specifically. So most buttons on your joystick will be numbered. You can see this by looking in the driver station, and pressing a button will light up a little light in your driver station. What number of light it is the number of the button on the joystick. Buttons on joysticks start from 1. There is no 0 button. This class creation returns a trigger my button. And to get it as a Boolean, where if it's true, if it's pressed, or false otherwise, you would do my button.get as Boolean. If you're running this in teleop periodic or something like that, ideally you would just call this on loop, and you would call this stuff once when you create your robot. Does anyone have any questions? One second, sorry. Okay, so to create a robot project, your options are to start from scratch, which in case you can install libraries, you have to install them manually. And it's recommended that anyone who's experienced with WPILib can start from scratch if they want. But we would also recommend that you can start from our skeleton project, where basically you use this command, you type it into your terminal/command prompt, and open the folder in WPILib VS Code, which hopefully you guys already have installed. We sent out installation instructions in the email that we sent out. So if you didn't get that, maybe check your inbox, check your spam, maybe it went to there. But for that, we would recommend the WPILib docs website. So up next is our lab section. So we're going to take a quick break because I believe our call is supposed to end in 10 minutes. So we might need to stop it and cause us and make us rejoin. So I'll ask my mentor about that real quick. Okay. No, pressing extend call takes me to a like a subscription plan. Okay, so we'll be going on to the lab shortly. Okay, we're just gonna pause for a second.
Well, I wish it would have told.
Okay, so we got our call time extended, so we can just move on to the lab. If you guys have any questions about what you've seen so far, you can ask them now. But other than that, we're going to go on to the lab section.
Main is the skeleton.
Okay, so in that case, we're going to move on to the lab section. So this is VS Code. I'm going to quickly close folder. So when you open your VS Code, right, it's probably going to look like this, and you're probably going to want to choose. If you haven't already, you're going to want to download the code from Git. So to do that, you can press Control J, and that will pop up a terminal like this. PowerShell on Windows. If you're on a Mac or Linux, it'll probably be Bash based. And then in this, you're going to want to type git clone, and then 1 second. And then oops, my bad. Sorry, guys. Then you're going to want to take the GitHub link that was posted in chat. So this one, which I'll leave on screen for a bit in case you guys still need it. And you're going to want to press enter, and it will clone the code from GitHub, which basically has the starter stuff that you kind of need. Does anyone have any questions so far? Or... Okay, so after that, you're going to want to do File, and then Open Folder. And you're going to want to choose the folder that your code is in. So we're choosing Programming Workshop 2024 and select folder. And this is going to open up your code in VS Code. So here we have source. Choose yes, you trust the authors. We're the authors. We promise you can trust us. But choose source, main, Java, and then this is pretty much where all your code is going to be written. Main is kind of the starting off point where, 1 second, where your code starts running. Robot container is where you're going to put a lot of code that you write. And eventually in this subsystem, we're going to end up putting some stuff. So when you first open VS Code, something might open up in your terminal. So for example, we had this open up here. Basically, it just tries building your code. Basically, it'll download a lot of files that it needs to be able to run your code and try executing that task. So it's still building for us. So we'll wait for that to happen. So usually this step can take a while. You can technically edit your code before it, but I would recommend waiting for it to build because then it'll give you nicer IntelliSense, which basically allows you to write your code with pretty fancy autocorrect and autocomplete. Yeah, so usually the first time you run one of these, it's going to take a while. It starts the Gradle daemon or daemon or whatever you like to call it, this thing right here. And so the next time you try building your code, it's going to be faster. But right now, it's taking a bit. So any second now. Sorry, guys. I wish I had some Jeopardy music, but there we go. It successfully built. It only took 3 minutes and 48 seconds. But next time, ideally, it'll take a little less time. So our first goal for the lab. Why won't it switch my tab? There we go. Okay. Thank you. So for the lab, our first goal is to run a motor while a button is pressed. So in our robot container, right, we have a robot in it. Actually, this isn't our robot container. This is our robot container. Navigate into the file that says robot container on the left. Pro tip. You should write your code in the right files. So here we have a little comment incentivizing us to create a controller to drive our robot. We're going to create that, we're going to need a joystick, as we showed in the code. So it's not the right button. Right around here. So joystick equals new joystick. So what you can do is you can type out joystick, and then this little drop-down menu is going to show up. And we're going to see joystick, joystick button, and joystick sim. You can either click on joystick, or if it's the top option, you can press the tab key, and then it kind of auto-completes it for you. Now, the benefit of doing that is not only does it auto-complete it, but it also imports it up here. So I didn't have this in my code earlier, but since I pressed tab, it automatically added it in, which is very helpful. So we'll do joystick, and let's say main joystick equals new, and we're using this new because we're creating an object of the joystick class. Then joystick, and let's go with port 0. So now we have a joystick, and as you see, our errors for the most part went away because we created our joystick properly. Now we're also going to want a button on this joystick. Let's call that button main button, right? So joystick button, or we can actually use a trigger here. Trigger. And I use tab there to automatically import it. Main button. equals new joystick button. As you see, I haven't completely completed it, but we can press tab to import it. And we're going to want to choose 1 as our ID so we can get the first button on it, because joystick buttons don't start counting from 0. They just don't. That's for some reason. So we have both our joystick now and our main button. Now, as our goal is to run a motor when a button is pressed, we're going to need to create a command to run the button. So if we go into subsystems and drive subsystem, we are going to have a little command here to run a motor. So a command is basically just a method that returns the type command. And you can pretty much just copy this syntax here. But public command, and then let's say run motor. And return run. And then this little syntax here. And inside of this, you can put code you want to run on your button press, basically. So we're going to want to run a motor on our button press, but right now we don't have a motor yet. So we're going to create a spark max for this. So can spark max. Which it appears I do not have. Now, if you don't have a spark max, that's likely because you don't have a vendor library imported. To import vendor libraries, specifically in this case, we're going to need the vendor library for Rev, right? Rev Robotics, which makes spark maxes. What you're going to want to do is look up WPI-lib vendor libraries. Click on third-party libraries, and then scroll down till you find the one that you're using. So we're going to be using Rev right here. But some other ones you might be using is Phoenix 6 or 5 if you're using the Talon SRX or the Talon FX. That's pretty much the only other one you'd be using right now. You're going to want to copy the link. And then in your project, press the W, manage vendor libraries, install new libraries online. And then you're going to want to paste the URL and press enter. And then press yes to run a build. Hopefully this one will take less time than the last one because we already have our Gradle daemon. So. If any of you guys have any questions, now's a great time to ask while we're waiting for it to build. And also write this down if you haven't already. Yes. So we have a question about creating the joystick here, or I think here, right? Yeah. So basically, when we create the joystick here, the question was basically why is it starting at 1, like because we're choosing to start at 1, or because it's choosing to start at 1? Is that kind of okay? So basically, when we're creating a joystick button, we have a joystick already, such as this thing right here, right? And the ID of the joystick button is basically just telling it that we're using, say, this button right here. So this button has an ID of 1, right? Any other button would have a different ID. Like this one would be 2. This one would be like 8 or something like that. The way joystick manufacturers make the joysticks, none of them have an ID of 0. So that's why we're using 1. You could use any number that is, I guess, below or equal to the number of buttons on the joystick. Yes. Yeah, so buttons start at 1. Joysticks start at 0. It's just a weird quirk of working with joysticks. So my build succeeded. It imported the vendor library. So now if I run if I write down can spark max, it shows up and I'm able to press tab to get my class imported up here again, right? That's one of the uses of pressing tab, and it makes sure all my typing is correct and whatnot. So can spark max, and let's call this motor. Just motor is good for now because we don't have any other motors. If you had more motors, a more descriptive name would work. But motor equals new can spark max tab. And we're going to go with, in our case, we actually have a physical robot. So I'm going to go check which motor we're going to run. We're going to go with 1 for us. But if you have another physical robot that you're doing this with, ask your mentor, or if you know yourself what port it's on, use that port instead. And for type, since we are running Neo 550s, I think, on our robot, or some type of Neo, I forget exactly which type. Since we're running the Neos, we're going to need brushless because Neos are brushless motors. If you were running a sim, that would be a brushed motor. 1 second. So, I mean, I would ask a mentor if your motor is brushed, though, anyway, just to make sure. But so here we're going to do motor type. And of course, we're going to tab on the first one, dot K and brushless. So now we have our motor created as motor. Does anyone have any questions? Okay, in that case, we will move on. So in our run motor command, we have this code here, which is basically saying that when this command starts, commands are like a special type of object that kind of have a start and an end. And when this one starts, while it's running, we're going to want to run any code that is in here. So any code in here will kind of run every 0.02 seconds while the command is running. In this case, we're going to want to have our motor run. So we're going to do motor dot set. And then since we're running at half speed, we're going to set it to 0.5. And then Control S to save that file. So this is our run motor command. And to basically connect it with our joystick, what we're going to do is we're going to go down to here in this configure bindings method. We're going to do main button and then dot wow true. And this is basically going to run whatever command you pass into it while the button is held down. So while it's true. And when the button stops being true, it's going to end the command. We already have our drive system subsystem. So we can do m drive subsystem dot run motor to get our command. And since it's a method, you need to call it. And then semicolon. And we have our command now. So when we press button 1 on our joystick, while it's held down, this command is going to be running. Now, one tip for working with VS Code is if you press Control and then you click on either a variable or a method name, it'll bring you to the code that has that method in it. Now, on Macs, it might be Command click, but I think it's Control click. Either way, there's one small issue with this code right now, so I wouldn't recommend running it on any robots yet. This runs this while the button is pressed down, but when the button is let go, it just stops running code. But our motor speed is still going to be set to 0.5, so it's going to keep running even when you let go of the button, even though the command itself ends. So we need to add an end to this command. So to do that, we can use a slightly different looking command constructor called run end. And basically, instead of just taking one of these funky little looking things, which are called arrow functions or anonymous functions, we can put another one in after it. And basically what this does is it tells it, this is what we want to happen while the command's running. This is what we want to happen when the command ends. So in our case, we're going to want to set that to 0 because we want the motor to stop when our command stops running. So now, if we press our button, it should run the motor, and then when we let go, the motor should stop. Does anyone have any questions about any of that? I'll show that command again. Okay, so we're actually going to deploy this code to our robot over here now. And to do that, you're going to want to go to the little W in the corner. Actually, before you do that, make sure your robot's powered on. If it's powered on and properly wired up, your indicator light should be orange. You're going to want to press W, then, well, actually, go down, make sure your Wi-Fi is connected to the robot. Okay, this is actually an interesting conundrum we have right now because I would love to connect my internet to the robot, but then my internet wouldn't be connected to the video call for a second. So, okay. So what I'm going to do real quick is we're going to get this code copied onto another computer, and then we're going to deploy it so we can see the code run. So you guys can work on that for a second, and we'll work on that. So if you have an actual robot you're following along with, now would be a great time to try deploying. If you are connected, the way you deploy is you press this W button. You need to basically connect to the internet signal of the robot. So for example, I would connect to 2539.2, which is the name of the robot. 2 is actually the name of the robot, and then 2539 is just our team number. But then you would do deploy by pressing on that button and typing deploy, and then pressing deploy robot code. And it's going to run a little thing in your terminal down here. It's going to try discovering RoboRio, and this is where my thing is going to fail because it's not going to find a RoboRio. Also, if you're doing this using the skeleton project, you're going to need to go into, you're going to need to search, press on this little search thing here, do 2539, and then you're going to want to replace it with your team number or whatever number you have your robot set to. So if you were, say, the Cheesy Poofs, you would do 254, and then just press enter. And you could replace it there, and that would replace our team number with your team number so you can properly deploy to your robot. Okay, so we got the code thing sorted out. We have a Ethernet cable now. USB to, okay, we have a USB cable now, but that should allow us to deploy. So if I go back to my little W, deploy robot code, it'll run through all its build stuff. My code was already built, so it probably shouldn't take too long on the build step. It finds it, and now we're actually going through with it, executing. Usually on most computers, this should only take around 30, 20 seconds. Took us 23, but now we have the code on this robot right here. So that's pretty cool. You're going to need a driver station if you're doing this on an actual robot. But if you already have that set up, you can enable your robot, right, with either the button, and your light should start flashing then if your robot's enabled. And if you press the right button in your joystick, which I would recommend going and checking your joysticks first to see which one is which, so you know which button is actually going to make your motor run. In this case, it's the trigger on this joystick. If we enable, and then I pull the trigger, it in fact runs one of our motors. Happens to be on the other side of the robot, but I think you might be able to hear it. So it is running this side. But our command does in fact work. And when I let go of the button, it stops the motor safely. If you like pull down your trigger and then the motor just keeps running, you can always press enter on the driver station. That stops the robot for safety purposes.
What if you hit space?
Also, hitting spacebar does stop the robot, but to be able to turn the robot back on, you'll need to actually physically restart the robot by turning the power off and then turning it back on. So I recommend the enter button.
Space.
Yeah. So space is pretty much the equivalent of an e-stop in an actual FRC match. Does anyone have any questions so far? Okay, so we had a question that was basically asking about why we are putting this stuff in a run end command instead of kind of just putting it in a periodic, like here, for example, which gets called once per schedule run, or putting it in like the robot periodic here. And the reason we do that is because our team and most teams use the command-based framework for Java. And one of the benefits of that is it makes it a lot easier when you start writing a lot of these methods to still be able to clearly bind them to buttons and to be able to switch between them. It gains you a lot of functionality in that kind of encapsulation of a process as like a start, a while it's going on, and an end, instead of just writing it in like an if statement, like button pressed and then run or whatever. Instead of writing it like that, if you write it in a command, it makes it easier to kind of switch what you're doing there's quite a few benefits. So we tend to write our code like this. If you're still working on this code or deploying it to your robot, that's fine. But we're going to move on to the next example now. So which is running a motor when a proximity sensor activates and a button is pressed. So to do that, what you're going to want to do is in our subsystem right here, we're going to need a new digital sensor, right? We're going to treat our proximity sensor as digital for now. So digital sensor, or digital input actually, is the name of the class. We're going to press tab to import that, and then proximity sensor. And then new, and then digital input on whatever port you have it plugged in on. On this robot right here, we don't actually have a proximity sensor, but we're just going to use channel 0 as our example proximity sensor. By the time we have this code deployed, we may actually have a proximity sensor on the robot though. So we have a pit crew kind of speedily working on the robot right now. It's wonderful. And by pit crew, I mean our program manager, Sean. So thanks to him. But yeah. So proximity sensor, digital input. What we want to be able to do is in robot container, we want to be able to kind of access whether that proximity sensor is pressed or not. So we're going to need a method to make that more public. So what we can do is do public, then Boolean, because we want to return a Boolean, whether or not the proximity sensor is activated, and then get proximity sensor. Now return, and then proximity sensor. And since it's a Boolean sensor, since it's digital, we're just going to do get. So here we have our method, and this method returns true if our proximity sensor is activated. So if we go back into robot container now, we have main button while true, and then we have this. So what we would recommend is taking this main button and doing a dot and then this syntax here again. Then drive subsystem dot get proximity sensor.
You want analog or DIO?
DIO.
DIO.
So pretty much this right here is checking if our main button is pressed and if our drive subsystem's proximity sensor is pressed. So this whole thing kind of acts as a button that's only true if the button is pressed and the proximity sensor is active. And then while that's true, our drive subsystem will run its motor. So I just got news that our proximity sensor is plugged in and it's on digital input channel 0. So we can actually try deploying this code and testing it out. So deploy again. If you guys have any questions, now is a great time to ask them while we wait for it to deploy. So our code successfully deployed. We're going to attempt to run this. We have a proximity sensor here. which I'll see. Okay. So if we enable and then we just pull our trigger, is it on? Is the proximity sensor activated right now? Okay. Is it in DIO 0? Oh. Okay. So it appears our digital proximity sensor, when it detects something, returns false, and when it doesn't, returns true. So if I pull the trigger right now, well, no one has their hand in front of the sensor, right? Let me see if I can get that sensor more visible. Sensor is right here, right? So if I pull the trigger, that wheel is going to spin up there. But if I put my hand over the sensor, it does not spin anymore. So you could kind of use this to like put it on the front of a wall or on the front of your robot. And then maybe your robot, it needs to drive into a wall. It sees the wall and it stops, right? So that's an example of using a proximity sensor. So. Thank you, guys. Do any of you guys have questions about that? If we, for example, wanted to make the robot run, in our case, when our hand was there, since we now know that our proximity sensor is returning the opposite of what I guess would make sense in most cases, we can do get proximity sensor, and then we can use the Boolean not operator on it, like this, which is an exclamation mark. And what that'll do is it will take this Boolean here, and if it's true, it will return false. If it's false, it will return true. Alternatively, that would probably be the best way to do this. Alternatively, you could make a trigger out of this. And triggers are kind of like buttons, but you can choose whatever you want to activate them instead of the press of a button. And in this case, it's going to be our proximity sensor being active. You can do dot not on it. Dot negate is the correct term. But this would do the same thing as using not. But that is a bit more complicated with syntax, so we won't use that for now. We'll just stick with the simple not operator. This is kind of like, if you're familiar with Python, just typing the word not. So for our final lab activity demonstration, we're going to be running the motor with the speed of our joystick, which is, I mean, at least in robotics, very common. Usually you have your joystick be hooked up directly to the speed that your wheels are going at, so you can pretty easily control your robot with your joysticks. So in this case, what we're going to want to do is where is it? Our drive subsystem. We're going to want to modify our run motor command slightly. So we're probably going to pass in, let's change this from a command to just a method that sets our motor to a certain speed. Or in fact, we can just create a separate one. But public void set motor speed, and then motor.set. And we're going to want to use variable speed as the input here. So double speed, set speed, and we can set our speed right there. Now, in a robot container, we're going to comment that out because we don't want to run our motor when we press the trigger anymore. We're going to get our joystick, right here, main joystick, get axis, get x axis, And this will get our new axis, and we can dot. Yeah, this gives us a double, which is the value of our x-axis. So every second, or I guess every tick, pretty much, we want to set the speed of our joystick to this new speed. So what we can do is, sorry, not set the speed of our joystick. What am I saying? Set the speed of our motor to this. So we're pretty much going to want to run m.drive subsystem dot set motor speed, not to 0, but to our joystick value. So we want to run this. But right now, this just gets run once when we configure our bindings. We still need it to be in a command. So to do that, you can do commands.run, and that will create a command. We still need to import commands, but I like just using tab to import it. So commands.run this. Now we're getting an error because we don't have the little arrow syntax at the beginning. What this basically tells Java is that you don't want to run this right away. You kind of want to run it later. And it gets it in a form where the method you're calling can call it later if it wants, but it doesn't have to call it now. So this command would do what we want, but we still need to get it to run. So one way to do that that's very common is using something called a default command. So if we use the drive system subsystem, and then we do set default command, and we pass this as the parameter for it, now by default, if it's not running any other commands, the drive subsystem is going to run this command. And also, commands have something called requirements, which are basically the subsystems they use when they're running. If you make a command inside of a subsystem, it automatically adds that subsystem as a requirement. Since we're making this outside the subsystem, we need to manually add it as a requirement. So we need to do m drive system subsystem and include it as a requirement. Alternatively, something you could do, if you don't want to include it as a requirement, is you could just replace commands with m drive subsystem. And that automatically includes it as a requirement too. So those are two separate ways of doing pretty much the same thing. I prefer the first way, but I think for a lot of people, the second way makes more sense. So now we're going to deploy this to the robot and see if it works. If you guys have any questions, you can ask them now. So. Okay, we have our code successfully deployed. So if we enable with our finger pretty close to the enter key in case something goes wrong, nothing happens yet. But if we move our joystick, the wheels do move. It might be a little hard to see, but I bet you could hear the sound. So in our case, the x-axis is left to right on our joystick. So if I push the joystick left, the motor runs. And then if I push it the other way, it runs pretty fast in the opposite direction. So that's how you control a motor with a joystick. And then I'm going to press enter to make sure I don't bump this thing and have the robot move everywhere. So that is the walkthrough of the lab, at least. If you guys have any questions, we'll still be on for a while, so you can ask them. But this QR code here, and I'll full screen this so you guys can see a bit better. This QR code here has a link to this presentation. And this QR code here, let me turn on the laser pointer. This QR code down here is a link to the GitHub page, specifically branch 1. So branch of week 1, which has example code for Spark Maxes, Talon SRXs, and Talon FX for all 3 of these examples, if you want to look at that. Any questions? Also, there is a feedback form. It's posted in the chat. So if you guys have feedback, you can put it there. Otherwise, the main presentation is done. You can stick around to ask questions if you want, but thank you. Thank you for coming. So, that's all.